We now solve some numerical problems in functions. Let us look at the question. Let f of x is equal to a1 tan x plus a2 tan x by 2 plus a3 tan x by 3 plus and so on etc. up to an tan x by n, where a1, a2, a3 etc. n are all real numbers and n is a natural number with mod f of x less than or equal to mod tan x for all x in the upper interval minus pi by 2 to plus pi by 2. Then what is mod a1 plus a2 by 2 plus a3 by 3 plus etc. plus an by n? That is the question. Let us understand, let us receive the things given in the data very carefully. Mod f of x less than or equal to mod tan x. It is the crucial information from the data. Moreover, observe the question. We require mod a1 plus a2 by 2 plus a3 by 3 plus etc. an by n. It is f of x is equal to a1 tan x plus a2 tan x by 2 plus a3 tan x by 3 and so on an tan x by n. That is data, but the required is a1 plus a2 by 2 plus a3 by 3 plus etc. You must be able to grasp that f dash 0 is asked. What is f dash x actually? a1 tan square x plus a2 into half into tan square x by 2 plus a3 into 1 by 3 into tan square x by 3 and so on plus an into 1 by n into tan square x by n. Thereby, what becomes to the nature of f dash 0? It is just nothing but the question asked, that is mod a1 plus a2 by 2 plus a3 by 3 and so on plus an by n. So, we have to take the decision to find mod f dash 0. Let us first find f dash 0. F dash 0 is nothing but limit as h tends to 0 f of h minus f of 0 by h minus 0. From the very fundamental definition of a derivative, there is the first principle of a derivative. Well, this is equal to limit as h tends to 0. What is f of 0? Automatically it is 0. So it is f of h by h. We don't want just f dash 0. We want to have mod f dash 0. Is nothing but modulus of this. Is nothing but modulus of this. This is the right occasion for us to use the important information from the data. That is mod tan x less than or equal to mod f of x less than or equal to mod tan x. So that this is less than or equal to limit as h tends to 0 mod tan h by h. Here we could have used mod f of x less than or equal to mod tan x. Everybody knows that mod tan h by h as h tends to 0 is 1. Hence this is equal to 1. Hence the answer is B. That is mod f dash 0 is less than or equal to 1. And mod f dash 0 is just nothing but mod a1 plus a2 by 2 plus a3 by 3 and so on plus an by n, which is the required. So the answer is B. The next question. He is asking us the domain of root of sine of cos x. What is the domain of square root of sine of cos x? The option 1 is closed interval 2n pi to 2n pi plus pi by 2 n belongs to I. Second option, closed interval 2n pi plus pi by 2 to 2n pi plus pi n belongs to I. Third option, closed interval 2n pi plus pi to 2n pi plus 3 pi by 2 n belongs to I. Fourth option, 2n pi minus pi by 2 to 2n pi plus pi by 2 closed interval n belongs to I. This is the question. Well, let us think of the answer. Write f of x is equal to square root of sine of cos x. Basically, as it is a square root function, for it being defined properly, we must take care that sine of cos x must be greater than or equal to 0. That is, cos x must be greater than or equal to sine inverse 0. But sine inverse 0 is 0. That is, cos x must be greater than or equal to 0. Let us imagine, let us think of the quadrant, rather the place where cos x is non-negative, either in the first quadrant or in the fourth quadrant. Such view can be directly seen from the fourth option clearly, that is closed interval 2n pi minus pi by 2 to 2n pi plus pi by 2 for any integer of course, that is n belongs to I, and this C is available in option D, that is option 4. The next question before us is, let f of x is equal to e power x plus sin x be defined on the interval closed interval minus 4 to 0. Then the odd extension of f of x in the interval minus 4 to 4, the closed interval minus 4 to 4 is, the first option is e power minus x plus sin x for all x in open interval 0 to 4. Second option is minus e power minus x plus sin x, x is in the interval open interval 0 to 4. Third option is e power minus x minus sin x, x belongs to open interval 0 to 4. And the fourth option is minus e power minus x minus sin x, x is in the interval open interval 0 to 4. The main thing here that you have to catch is he requires the odd extension of f of x. So you choose that option which gives us an odd function. If you look at all the four options available, it is very easy to identify that the second option minus e power minus x plus sin x gives us an odd function. That is, if you write say g of x is equal to minus e power minus x plus sin x, then what is g of minus x? This is minus e power x plus sine of minus x, that is equal to minus e power x minus sine x. This is equal to minus of e power x plus sine x. This is nothing but minus f of x. Of course, this is an extension of f of x we are believing. Therefore, this option gives us an odd extension. It is nothing but the basic requirement for f of x to be called an odd function. Therefore, the right option is the second option. The next question. If for non-zero x, 2 into f of x square plus 3 into f of 1 by x square is equal to x square minus 1, then f of x square is equal to, it's a beautiful question, a famous question. It has been given that 2 into f of x square, let us have it, 2 into f of x square, 2 into f of x square plus 3 into f of 1 by x square is equal to x square minus 1. What is f of x square? He is asking us. The options are, the first option 3 plus 2x power 4 minus x square by 5x square. Second option 3 minus 2x power 4 plus x square by 5x square. The third option 3 minus 2x power 4 minus x square by 5x square. And the fourth option is 3 plus 2x power 4 plus x square by 5x square. Now, let us think of what is the required one. F of x square is required. So, f of 1 by x square is not required. F of 1 by x square is not required. Let us plan it. 2 into f of x square plus 3 into f of 1 by x square is equal to x square minus 1. He has given. Name this equation as 1. From this, let us replace x square by 1 by x square. What is going to happen? 2 into f of 1 by x square plus 3 into f of x square is equal to 1 by x square minus 1. Or this is 1 minus x square by x square. Call this equation 2. You just solve these two to get f of x square. It is an easy manipulation. Multiply the first equation with 2, second equation with 3 and subtract. You will be going to have directly f of x square. That is, first equation into 2 implies, what are you going to have? 4 into f of x square plus 6 into f of 1 by x square is equal to 2x square minus 2. What are you going to do about the second equation? Multiply the second equation with 3. What do you have? 3 into 3, 9 f of x square. 3 into 2, 6 f of 1 by x square. 3 into 3 minus 3x square by x square. Now you just subtract this one from this. What are you going to have? 9f of x square minus 4f of x square is 5 into f of x square. These two will go away and that becomes 3 minus 3x square by x square minus 2x square minus 2. You get the LCM and get it simplified. It's very easy to note that this is the third option is the correct option, that is 3 minus 2x power 4. This is 3 minus 2x power 4 minus x square by 5x square. From where you are going to get this 5? This is all 5 into f of x square. So to get f of x square, this must be the right option, that is the third option is the right option. The next question, the domain of the function f of x is equal to sine inverse of log of x square by 2 to the base 2. The first option is closed interval minus 2 to 2. Second option is closed interval minus 2 to minus 1. Third option is closed interval 1 to 2. And the fourth option is closed interval minus 2 to minus 1 union closed interval 1 to 2. What is the big function basically given? F of x is equal to sine inverse of log of x square by 2 to the base 2. First of all, it is a sine inverse function. We all know that the domain of sine inverse function is minus 1 to 1. So, f of x belongs to R implies minus 1 less than or equal to log x square by 2 to the base 2 less than or equal to 1. If x lies between minus 1 and 1 only, sine inverse x is going to be defined. You call this sum A. Sine inverse A is possible to be defined if minus 1 less than or equal to A less than or equal to 1. Well, let us make use of this. From this, you can have 2 power minus 1, that is 1 by 2 less than or equal to x square by 2. From this, what can you have? 2 power 1 is 2 less than or equal to 2. 2 power 1 is 2. This implies multiply this with 2. 1 less than or equal to x square less than or equal to 4. 1 less than or equal to x square less than or equal to 4. From this, we shall be having two inequalities, that is x square minus 1 greater than or equal to 0 and x square minus 4 less than or equal to 0. So, the intersection of these two domains gives us the correct answer. X square minus 1 greater than or equal to 0, therefore x should not lie between minus 1 and 1. X square minus 4 less than or equal to 0, therefore x should lie between minus 2 and plus 2. Clubbing these two, we trace the answer to be minus 2 to minus 1 union 1 to 2 as the right answer. This is the combination of these two domains. For x square minus 1 greater than or equal to 0, x should not lie between minus 1 and 1, but x square minus 4 less than or equal to 0, so x should lie between minus 2 and 2. Intersection of those two is closed interval minus 2 to minus 1 union 1 to 2 is the right answer. That is the fourth option among the given options is the right answer. The next question, f is a real function, that is from R to R, satisfying f of x plus y is equal to f of x plus f of y for all xy belong to R, and f of 1 is equal to 7, then sigma r is equal to 1 to n f of r is, what is given? F of x plus y is equal to f of x plus f of y. That is the useful weapon with us for, of course, in the given problem. Also, it is given that f of 1 is 7 and f of 1 is 7. What is required? Sigma f of r running from 1 to n. Sigma f of r running from 1 to n. That is f of 1 plus f of 2 plus f of 3 plus f of 4 plus etc. up to f of n, which you require. Well, what is f of 1 is 7 is given. What is f of 2? It is f of 1 plus 1. Using this, f of 1 plus f of 1. That is 2 into f of 1. That is 2 into 7. What is f of 3? F of 1 plus 2. F of 1 plus f of 2. F of 1 is 7. This is 2 into 7. Altogether 3 into 7. Similarly, you can trace that f of 4 is equal to 4 into 7. F of 5 is equal to 5 into 7. And so on, etc., etc. F of n is equal to n into 7. Now, what is required? Sigma f of r is equal to 1 to n is required. This is nothing but sigma r is equal to 1 to n r into 7. F of n is n into 7, f of r is r into 7. This is equal to 7 into sigma r is equal to 1 to n. Therefore, the answer is 7 into, what is sigma r? 1 plus 2 plus 3 plus etc. etc. up to n is just nothing but n into n plus 1 by 2. Amongst the given options, the second option is the right option. 7n into n plus 1 by 2 is the right options. As we see that the options are, first option is 7 into n plus 1 by 2, second option is 7n into n plus 1 by 2, third option is 7n by 2, fourth option is 7n into n plus 1. So among all of them, the second option, that is 7n into n plus 1 by 2, is the right option. The question is, again f is a real function, that is r to r, and f of x equal to x mod x. He is asking the nature of the function. The first option is 1 1 but not on 2 but not 1. Second option is on 2 but not 1 1. Third option is both 1 1 and on 2. Fourth option, neither 1 1 nor on 2. Let us observe the function very carefully so that we may be able to decide. F of x is equal to, he has given x mod x. Implies f of x has now 3 different cases. Case 1, let us assume that x is positive. Then mod x is x. X into x becomes x square if x is greater than 0. Case 2, what happens when x is equal to 0? If it is 0, f of 0 is 0 into mod 0 is again 0 is equal to 0 if x is equal to 0. If x is less than 0, what happens? Mod x is minus x. X into minus x is minus x square. So this is minus x square if x is less than 0. Therefore, f of x has 3 different answers in 3 different cases. It is a very easy matter to see, to look at, that f is both 1 1 and on 2. On 2 because for positive numbers also you will be having f of x such that f of x equal to x square. For negative numbers also you will be having here. Therefore, it is both 1 1 and on 2. That is, the third option is the right option amongst the given. Here the question is, f is a real valued function satisfying f of x plus f of x plus 6 is equal to f of x plus 3 plus f of x plus 9. Once again, f of x plus f of x plus 6 is equal to f of x plus 3 plus f of x plus 9. What is f of x? He is asking us to express f of x in terms of the first option f of x plus 3, second option f of x plus 6, third option f of x plus 9, fourth option f of x plus 12. Which one might be the correct one? Let us have a look over. What is the data here? What is given? F of x is equal to f of x plus f of x plus 6 is equal to, that is the data, f of x plus 3 plus f of x plus 9. Call this relation 1. Now let me replace x by x plus 3 in the given item. What are you going to have? F of x plus 3 plus f of x plus 9 is equal to f of x plus 6 plus f of x plus 12, isn't it? Observe these two relations carefully. RHS of the first relation is nothing but LHS of the second relation. So equating these two, what are you going to have? F of x plus f of x plus 6 is equal to f of x plus 6 plus f of x plus 12. Cancelling f of x plus 6, you are going to get the required f of x is nothing but f of x plus 12. Hence, what is the right option? The fourth option is the right option. Here the question is, once again a real function is given here, that is f from R to R, defined by f of x is equal to log of x plus root of x square plus 1. One of the famous functions which we generally come across. Regarding this function, he is giving us two particular statements. Let us see. In the statement 1 is f of x plus f of minus x is 0. Statement 2 is f is an odd function, and then which one of the following is correct, he is asking of the question. Two statements are given. Regarding those two statements and the function, he is giving four options. In the first option, only the first statement is correct. Second option, only the second statement is correct. Third option, first and second are correct, and first statement is the correct explanation of the second. Fourth option, first and second statements are correct. First statement is not the correct explanation of the second statement. Let us see. Let us observe the statements first of all. What is the first statement? F of x plus f of minus x equal to 0. Statement 1. I would like to look at what is given. F of x plus f of minus x is equal to 0. From this, f of minus x is equal to minus f of x. Of course, this is the basic character directly from the definition of an odd function. Well, what is the second statement? What is the second statement? F is an odd function. F is an odd function. Now, let us verify if f of x is equal to log of f of x is equal to, what is the basic function given? F of x is equal to log of x plus root of x square plus 1. If this happens to be an odd function really, then the second statement would be correct. And this is of course the straight explanation of being an odd function. Isn't it? Therefore, it is necessary first of all to check whether f is an odd function or not. Let us see. What is f of minus x? This is nothing but log of minus x whole square is x square, root of x square plus 1 minus x. This is equal to log of, let us rationalize that so that you will be having 1 by root of x square plus 1 plus x. This is nothing but log of x plus root of x square plus 1 whole to the power of minus 1, and that minus 1 becomes to the front portion so that it becomes minus of f of x. F of minus x is equal to minus f of x. We are able to observe. So this is an odd function is correct. So second statement is exactly correct. Surely this statement is the explanation, correct explanation of the second one. Therefore, by observing all these three, we notice that the third option is the correct option. The next question is f of x is equal to cos of integral part of pi square x plus cos of integral part of minus pi square into x. Then, which of the following is right? In the present function, integral part of this particular symbol has been given. What do you mean by this one? Integral part of A is nothing but the greatest integer less than or equal to 1, or the integral part. Actual function given here is f of x is equal to cos of integral part of pi square x plus cos of integral part of minus pi square x. Then the first option is f of pi by 2 is equal to minus 1. Second option is f of pi is equal to 1. Third option is f of minus pi is equal to 1. Fourth option is f of pi by 4 is equal to 2. To choose the correct option, let us first study f of x very carefully. To know this, let us recall pi square lies between 9 and 10. 9 and 10. So integral part of pi square is 9, where integral part of minus pi square is minus 10. On the number line, it's very easy to notice that. You see, this is 9. This is minus 9. Say minus 10. Pi square is 9 point something. Then integral part is 9. Minus pi square is minus 9 point something. Somewhere else here it lies. So its integral part is minus 10. That you have to catch. Therefore, f of x is therefore equal to integral part of pi square is 9. So it is cos of 9x plus integral part of minus pi square. Minus pi square is minus 10, and cos of minus 10x is cos 10x itself. This is the original function given. Now you check out the first option. What is the first option? F of pi by 2. What is f of pi by 2? F of pi by 2 is equal to cos of 9 pi by 2 into x. X is pi by 2. 9 pi by 2. What is cos 9 pi by 2? Is 0. Why? Because cos function vanishes at odd multiples of pi by 2. And cos of 10 pi by 2s. 10 pi by 2s means 5 pi. Cos 5 pi is of course minus 1. Hence the answer is minus 1. F of pi by 2 is equal to minus 1 we are able to have. So what is the right option? The first option is of course the right option. Here the key part lies here in assuming integral part of pi square and integral part of minus pi square. Thereby you will be getting f of x the accurate definition. So the right option is the first option. Now the question is, the domain of the function f of x is equal to 1 by x plus sine inverse x plus 1 by root of x minus 2. What is its domain? The first option is closed interval minus 1 to 1 minus singleton 0. Second option is closed interval minus 1 to 1. Third option is open interval minus 1 to 0. And the fourth option is empty set. Let us see. It is very easy to observe that f of x is a combination of three different functions. 1 by x plus sine inverse x plus 1 by root of x minus 2. Here we are able to have three different functions. So we have to notice domain of the first one, domain of the second one, domain of the third one. So the actual domain is, what is the domain of 1 by x? R minus singleton 0. Intersection. What is the domain of sine inverse x? Closed interval minus 1 to 1. Intersection. What is the domain of root of x minus 2? For 1 by root of x minus 2, we should take care that x minus 2 is greater than 0 and x minus 2 definitely not 0. So x is greater than 2. Therefore, open interval 2 to infinity. It's very clear to look at this intersection that this intersection is phi. There is no common point here. So this intersection is phi. Phi intersection any other set is again phi. Therefore, the correct domain is phi. So such a function cannot be defined at all for any real value of x. So what is the right option? Fourth option is the right option. Now the question is, f from R to R, once again a real function, is defined by f of x is equal to sine of integral part of x into pi plus tan of integral part of x into pi by 1 plus integral part of x whole square. We all know that this symbol integral part of x denotes the largest integer less than or equal to x, and it is also read as integral part of x. Then the range of f, he is asking us, what is the range of f? The first option, closed interval minus 1 to 1. The second option, the set containing minus 1 and 1. The third option, singleton 1. And the fourth option, 0. Actually, what is the function given here? F of x is equal to sine of integral part of x into pi plus tan of integral part of x into pi by 1 plus integral part of x whole square. This is the function given. What do you mean by integral part of x? By the very name itself, it indicates it is an integer. Let it be some n. Sin n pi, 0. Tan n pi, 0. 0 plus 0 by 1 plus n square is again 0. So this is always 0 for all x belongs to R. Undoubtedly. Therefore, it is a constant function whose range contains just one and only one element, that is singleton 0. Therefore, among all the four options given, the fourth option is the right option. It's very easy to catch and notice. Why? Because integral part of x is just nothing but an integer. For any real value of x, it is an integer. Therefore, sin n pi is 0, tan n pi is 0. By the nature of sine function and tan function, it is easy to catch that. Hence, the answer is, range of the function is singleton 0, that is the fourth option is the right option. In this question, again he is asking us to find the range of a function. Range of the function f of x is equal to 3 by 5 plus 4 sine 3x is. 3 by 5 plus 4 sine 3x is. First option, closed interval 1 by 3 to 3. Second option, closed interval 1 by 3 to 1. Third option, closed interval 1 to 3. Fourth option, open interval minus infinity to 1 by 3 union open interval 3 to infinity. Let us have a check. F of x is, what is f of x? 3 by 5 plus 4 sin x. Let us recall that range of the function 1 by a plus b sin x, whenever a greater than b, is 1 by a plus b to 1 by a minus b. Let us recall it. And it can be used when and only when a is greater than b. Yes, according to that, 1 by 5 plus 4 sin x. This belongs to, come on, 1 by a plus b. 5 plus 4 is 9. A minus b. 5 minus 4 is 1. But we are asked to find 3 by. So it is 3 by 5 plus 4 sin x belongs to 3 by 9, 1 by 3. 3 ones are 3. Therefore, the range of the function is closed interval 1 by 3 to 3. That is the first option. And it is of course an easy matter to discuss with that. This can be obtained by using sin x lies between minus 1 and 1. 4 sin x lies between minus 4 and 4. 5 plus 4 sin x lies between 5 plus and 5 plus. 5 minus 4 to 5 plus 4. 3 by that, etc. It can be imagined like this, so that the answer is closed interval 1 by 3 to 3. Now the question is, f is a function from n to z, set of natural numbers to set of integers. It is defined by f of n is equal to 2 if n is equal to 3k, k belongs to z. F of n is equal to 10 minus n if n is 3k plus 1, where k is an integer. And it is 0 if n is equal to 3k plus 2 for k belongs to z. Then the question is, what is set of all n such that f of n is greater than 2? Set of all n such that f of n is greater than 2. That we require. Set of all n such that f of n is greater than 2. What is this set? You observe the definition. F of n has 3 different answers. One answer is 2 when n is 3k. Another answer is 10 minus n. When n is in the form 3k plus 1 and is 0 if n is in the form 3k plus 2. Out of all these, f of n is greater than 2 may happen. Here it cannot happen, here it cannot happen because it is 2 and it is 0. So, the clause f of n greater than 2 may not be fulfilled in these two cases. The only hope for us is in this case only. Therefore, set of all and f of n greater than 2. For that, we must have you seek when can this 10 minus n is greater than 2. That is the only case. If this definition is going to be used, then n must be in the form n is equal to 3k plus 1. N is equal to 3k plus 1. Therefore, 10 minus n is greater than 2. That is 8 is greater than n or n is less than 8. N is less than 8. N is less than 8 and n is in the form 3k plus 1. 3k plus 1. Come on, check among the options. If you take k is equal to, if n is less than 8, what are the possibilities? In the form 3k plus 1, k is an integer. If k is equal to 0, n is 1. Less than 8, okay. If k is 1, 3 1s are 3, 3 plus 1, 4. Less than 8, okay. If n is 3, n is 2, 3 2s are 6, 6 plus 1, 7. 7 is also possible, less than 8. Therefore, the possible things here are 1, 4, 7. N can be 1 by taking k is equal to 0. N can be 4 by taking k is equal to 1. N can be 7 by taking n is equal to 2. That's all. That's all. If you take n is equal to 3, then n becomes 10. And we should have less than 8 only. So what is the right option? 1, 4, 7. That is the second option among the given is possible. The right answer is the second option. As the given options are, first option is 3, 6, 3. Second option is 1, 4, 7. Third option is 4, 7. And the fourth option is singleton 7. Among all of them, the right answer is 1, 4, 7. We have seen they are the natural numbers which are less than 8 and in the form 3k plus 1. N is equal to 3k plus 1. So that is the right option. That is the second option. The question is, we are asked to have the range of x square plus 4y square plus 9z square minus 6yz minus 3zx minus 2xy. One of the famous questions which has been asked once upon a time in JEE mains also. Yes, let us observe the range. The first option is empty set phi. Second option is the entire set of real numbers. The third option is closed interval 0 to infinity. The fourth option is minus infinity to 0. Which one is the right option? Let us have a check. What is the given function? X square plus 4y square plus 9z square minus 6yz minus 3zx minus 2xy. This can be written in the form x square plus 2y whole square plus 3z whole square minus 2y into 3z minus x into 3z minus x into 2y, which clearly appears in the form a square plus b square plus c square minus ab minus bc minus ca, with in the place of a what are you having? X. In the place of b what are we having? 2y. In the place of c we have 3z. This again can be written in the form half of a minus b whole square plus b minus c whole square plus c minus a whole square. One of the standard identities we have. This c is definitely greater than or equal to 0. Why? Because sum of 3 perfect squares. None can be negative. Therefore, it is always greater than or equal to 0. Hence, the range of this expression, rather the function, is closed interval 0 to infinity. So, what is the right option? The third option is the right option. The key part here lies in this way of thinking. You must be able to write this expression in the form a square plus b square plus c square minus ab minus bc and minus ca, which in turn gives half of a minus b whole square plus b minus a whole square plus c minus a whole square, which is a well-known expression. It can never be negative. Hence, the range of this function is closed interval 0 to infinity. That is the third option is the right option. In this question, he is asking us to have the range of an expression. The range of x square minus x plus 1 by x square plus x plus 1 is the first option, closed interval 1 by 3 to 3. Second option, closed interval 1 by 3 to 1. Third option, closed interval 1 to 3. Fourth option, open interval minus infinity to 1 by 3, union closed interval 3 to infinity. Yes, here f of x is a quotient, of course, of two quadratic expressions, namely x square minus x plus 1 by x square plus x plus 1. According to the customary procedure to have its range, we generally take it to be some y, cross multiply, thereby getting a quadratic equation in x connecting y's, and as x is real, as it is a real function, x must be real, roots of that quadratic equation must be real, that the discriminant must be greater than or equal to 0, thereby you will be getting a quadratic inequality connecting y, and hence you will be able to have the range of the expression. This takes time, say some 1 or 2 minutes. Without doing that, we could have developed a mechanism for this. What is that mechanism? Let me name D1, discriminant of the numerator. What is the discriminant of the numerator? B square minus 4ac, 1 minus 4 minus 3. D2, discriminant of the denominator. What is that? B square minus 4ac, again minus 3. Let me name A1, B1, C1, A2, B2, C2. And the mechanism before us is D2 into y square plus 4 into A1 C2 plus A2 C1 minus 2 into B1 B2 into y plus D1 greater than or equal to 0. It is a famous inequality. Of course, it is made famous by applying for many number of times. Let us do that. What is D2? Minus 3y square plus A1 C2 plus A2 C1. Come on. 1 into 1 plus 1 into 1 is 2. 4 2s are 8 minus 2 into B1 B2. What is B1 into B2? Minus 1 into 1 is minus 1. Minus 1 into y plus D1. What is D1? Minus 3 greater than or equal to 0. So that it is minus 3y square plus 10y minus 3 greater than or equal to 0 is equivalent to say 3y square minus 10y plus 3 less than or equal to 0, or equivalently 3y minus 1 into y minus 3 less than or equal to 0. We can easily trace that y lies between, come on, 1 by 3 to 3. Therefore, range of the expression is 1 by 3 to 3. What is y? We have named this f of x is equal to some y, so that we could have had y lies between 1 by 3 and 3. What is the right option? The first option is the right option, that is closed interval 1 by 3 to 3. In the question, he is now asking us to find the range of a function. What is the function given? Mod x minus 2 plus mod x minus 5. What is the function asked here? F of x is equal to mod x minus 2 plus mod x minus 5. He has asked. The first option is closed interval 2 to infinity. The second option is closed interval 3 to infinity. The third option is closed interval 4 to infinity. And the fourth option is closed interval 5 to infinity. Which is the correct one? Here, one should keep one particular thing in mind. F of x is equal to mod x minus 2 plus mod x minus 5. It is necessary for us to observe the nature of f of x at different places on the real number line, behind 2, between 2 and 5, beyond 5. Altogether, 3 cases will arise. Let us observe what happens when x is less than 2. X is less than 2. What happens? X is less than 2. In this case, x is less than 2 means x minus 2, in the place of x minus 2, what can you write? 2, 5. Here x is less than 2. The distance with mod x minus 2 is nothing but distance between x and 2. That is, distance between x and 2 is 2 minus x or x minus 2. 2 minus x. This is equal to 2 minus x. Again, mod x minus 5. This is x, this is 5. X is less than 5. Distance between x and 5 is 5 minus 6. This is 5 minus 6. So, 2 minus 6 plus 5 minus 6. Isn't it? This is equal to 5 plus 2, 7. 7 minus 2x. 7 minus 2x. As is x is less than 2, this is 7 minus 2x is x is less than 2. Therefore, 2x is less than 4. 2x is less than 4. So, 7 minus 2x. X is less than 2. So, 2x is less than 4. Minus 2x is greater than minus 4. 7 minus 2x is greater than 7 minus 4. This is greater than 3. In the first case. Good. If x is equal to 2, what happens? X 2 minus 2 is 0. X minus 5 is 2 minus 5 is 3. 0 plus 3. X is equal to 2 implies f of x is equal to 3. F of x is equal to 3. And between 2 and 5, what is the nature of f of x? Between 2 and 5, suppose here is x. Here is this. F of x is equal to, come on, imagine, between 2 and 5, here is x. X is greater than 2. The distance between this is mod x minus 2 is nothing but x minus 2. But here x is less than 5. Distance between x and 5 is 5 minus 6. This is 5 minus 6. Minus 6 and plus x leaving you. So that it is 3. Between 2 and 5, f of x is 3. At x is equal to 2, 3. X less than 2, greater than 3. If x is 5, if x is exactly 5, here also what is f of x? This is 0, 5 minus 2 is 3. In almost all these cases, either 3 or greater than 3. There is still one more case is remained here. What happens when x greater than 5? Here also we can easily observe that x is greater than 3. By clubbing all these cases, we will be able to trace that the range of f of x is always greater than 3 or equal to 3 out of all the available options. What is the right option? The second option is the right option, that is closed interval 3 to infinity. As f of x is either is equal to 3 or greater than 3 in almost all the cases. Therefore, the range of f of x is closed interval 3 to infinity. The second option is the right option. In this question, the main question is, he is asking us the range of a particular function. The function is f of x is equal to 7 minus xp x minus 3. F of x is equal to 7 minus xp x minus 3. And the given options are, the first option, set containing 1, 2, 3. Second option, set containing 1, 2, 3, 4 and 5. Third option, set containing 1, 2, 3 and 4. Fourth option, 1, 2, 3, 4, 5 and 6. Let us have a look over this. To define f of x, there are certain basic precautions. This x minus 3 must be non-negative. 7 minus x is positive. And 7 minus 6 is greater than or equal to x minus 3. These are all the restrictions. First of all, x minus 3 must be greater than or equal to 0. Then x is equal to 3, possible, 4, 5, 6 and so on. They are possible. Let us have a check how many of such things are possible. If x is equal to 3, then what is f of 3? 7 minus 3, 4, p 0. What is 4p 0? 1 is possible. If x is equal to 4, what happens? F of 4, is it possible to define? 7 minus 4 is 3, p 4 minus 3 is 1. 3p1 is 3. Again, x is equal to 5. Is it possible? Are you able to find f of 5 or not? Let us have a check. What is f of 5? 7 minus 5, 2. P, 5 minus 3, 2. 2p2 is 2 factorial. That is 2 is possible. If x is equal to 6, is it possible or not? Let us see. F of 6, 7 minus 6 is 1. P, 3 has no meaning at all. Therefore, x is equal to 6 does not belong to the domain of the function. Therefore, the domain is 3, 4, 5 and the range is 1, 3, 2. Therefore, range of the function is equal to 1, 2, 3. Set containing 1, 2, 3 only. Therefore, the first option is the correct option among the 4 given options. The range of the function f of x is equal to 2 plus x by 2 minus x. X is not equal to 2 is. It can be done in 2 ways. Of course, here the options given are: first option, entire real number system; second option, r minus of singleton set containing minus 1; third option, r minus singleton 1; fourth option, r minus 2. Here, let us recall a very simple formula. F of x is equal to ax plus b by cx plus d and x not equal to minus d by c. In this case, we can see that f inverse of x is equal to minus of dx minus b by cx minus a. From earlier algebra, we can trace it. Here, f of x is equal to, what is the function given? 2 plus x by 2 minus x, and I like to write it as x plus 2 by minus x plus 2. Of course, x not equal to 0. From this directly you will be having f inverse of x is equal to minus of, dx minus b, that is 2x minus 2 by cx minus a minus x minus 1 minus x minus 1 is nothing but 2 into x minus 1 by x plus 1. What is it necessary to find f inverse of x? We are supposed to have the range of f. Range of f is nothing but the domain of f inverse x. F inverse x is equal to 2 into x minus 1 by x plus 1. So what is its domain? The denominator x plus 1, it shouldn't become 0. Therefore, domain here is r minus singleton minus 1 is the domain of f inverse, and of course range of f. Yes, f and f inverse are related in such a manner. Domain of f inverse is nothing but range of f, hence the range of f is r minus singleton minus 1, hence the second option is the right option. This is of course directly obtained from the earlier algebra. Not only that, it is not impossible to get f inverse directly. By supposing f of x equal to some y or so, get the value of x, you will trace f inverse x is that very simply and directly. Yes, see, the right option is second option, that is r minus singleton containing minus 1 is the right option. In this question, we are asked to find the domain of a function. The function given is f of x is equal to 3 by 4 minus x square. F of x is equal to 3 by 4 minus x square plus log of x cube minus x to the base 10. This is the function given, and we are supposed to have the domain of the function. The first option given is open interval 1 to 2. Second option given is open interval minus 1 to 0 union 1 to 2. The third option given is open interval minus 1 to 0 union open interval 2 to infinity, and fourth option is a set containing union of 3 different intervals, namely minus 1 to 0 union open interval 1 to 2 union open interval 2 to infinity. Let us have a check. Well, here f of x is a combination of 2 different functions. What are the functions? Number 1, 3 by 4 minus x square, and the other is log of x cube minus x to the base 10. Here you have to trace the domain of this and domain of that. Intersection of these two domains gives you the correct domain. For this, domain of f is equal to 4 minus x square. Set of all x is such that 4 minus x square not equal to 0. Intersection. Here to define this, what precaution is to be taken? Set of all x is such that x cube minus x is greater than 0. Greater than 0 or greater than or equal to 0? Greater than 0. Here, 4 minus x square should not vanish. What does it mean? X square not equal to 4. What does it mean? X not equal to plus or minus 2. This is equal to minus 2, 2. These are the two values that x should not take. That is r minus 2 to 2. This is the particular domain here. Intersection here. X cube minus x. Think of x cube minus x separately. X cube minus x greater than 0. That is x into x square minus 1. X minus 1 into x plus 1 greater than 0. You have the idea on the real line. This is minus 1. This is 0. This is 1. Here plus minus plus minus. What should you have? Greater than 0. Greater than 0 means minus 1 to 0 union 1 to infinity. Isn't it? So minus 1 to 0 union 1 to infinity. Minus 1 to 0 union 1 to infinity. Therefore, what is to be taken? From minus 1 to 0 union 1 to infinity, you are supposed to omit two numbers, namely minus 2 and 2. This can be had directly in the option 4, fourth option. Minus 1 to 0, union 1 to 2, union 2 to infinity. There minus 2 is already omitted and 2 is also omitted in the union of the intervals. Therefore, what is the right option? The fourth option among them, that is minus 1 to 0, union 1 to 2. 2 is not to be taken, union 2 to infinity. So this is the right option. That is, fourth option is the right option among the four given options.